So we did Monte Carlo simulation last time, and these are some of the keywords highlighted. One are the keywords
Okay.
which are important based on which questions may come. Okay. The next one is resampling. So resampling means basically you are creating more samples with one sample. That is resampling. How can you create more sample? Which is also called, one of this technique is bootstrap resampling. Bootstrap means basically you are creating more sample with the existing sample. Okay, say for example, or with the data, given data. Say for example, you have been given data something like, imagine numbers are like this: 25, 18, 19, 21, 24, 27, 32, 31, 29. These are the data given to you, limited data. So what you can do is, with this you can create many more data. So say for example 25, 25, 18, 21, 27. In whichever way you can create this many numbers of data: 18, 19, 21, 21. As in basically you will keep creating more and more data. You are resampling with the given data.
Okay.
That is called bootstrap resampling. So
And
we
what
draw
is this?
repeated sample of size n from the full data set. So this is the full data set, first one. From the
Okay.
full data set, you can keep creating repeated samples, okay, of size n. So this 1, 2, 3, 4, 5, 6. So 6 numbers samples you can keep creating, replacing the sampled observation each time so that they might be redrawn in another sample. That means if you are taking 25 here, here also 25 can come.
Okay.
Okay.
And what is this used for? Bootstrap sampling.
See, these all are tools. That means you can use it in multiple, products. So multiple products means what? See, basically, for example, when you don't have enough data or when you cannot get enough data, then how
Okay.
can you use the existing data? Say, for example, um, in something new innovation is happening. Say, for example, let's say ethanol. You heard about this ethanol being mixed with petrol.
Yes, yes,
You
I
heard
did.
about it? Okay.
Yeah.
So now imagine they want to take a survey about how many people will buy car after the introduction of ethanol. Now, so you are going and checking, asking the people, because actually you will come to know only later stage, right? Once it is implemented, once people buy, then only you will get more data. But beforehand, how will you get the data? So you have very limited data. Okay, beforehand, very few people are buying. So on that basis, you will do various permutation combinations to find out what is the possibility of people buying.
Okay.
You understood this one? So
Yes.
when you do not have enough data or you don't want to get enough data, why? Because maybe you have to incur cost to get that data. Okay.
Okay.
Then other example could be EV vehicle. Now we don't know EV vehicle how many people will be interested in, let's say, because EV vehicle is also something new in the market, right? So
Yes.
EV vehicle data, we don't know what will be the interest of the people because it is more expensive than a normal one, but it is good for the environment. Okay. So now we don't have much data. So with the given data, how will you create more data and then you study from different angle, then you can study. So if this data picks up, then what is the mean you are getting? If this data picks up, what is the mean? If this data picks up, what is the mean? So in different angle, you will study what are the chances, what will be the mean. Okay, or anything you can study from the existing data. Basically you are seeing the data, these are all the outcomes, no? So these outcomes can come in different angle. All these are different angle. Okay, so you are studying the data.
Okay.
Yeah, that is bootstrapped resampling. Bootstrap means from the existing only. So bootstrap is another method for generating data inputs to use in simulation, because we are simulating, we are creating many more data here. See, often we do not have data for population. Many times we will not have data for population, or it might be
Yeah.
too costly to get the data.
Okay.
So reading 7, estimation and inference. So again, this is the extension only. So probability sampling. So where probability comes into play. Okay, random sampling. Random sampling means everything will have equal probability. That is called random sampling. Okay, equal probability is random sampling. Simple random sampling. Okay, non-probability sampling means what? Non-probability sampling, we will see. Non-probability means, where you are collecting data based on the judgment, and based on imagine you have been asked to find out like how many people are waking up at 6 o'clock in the morning in Mumbai today. You take a survey. So now where will you take this survey from? Ideally, you should go to different parts of the city and then take this survey. But what will you do? You will just ask your friends. So what time they are getting up, that is your survey. Survey is done. That is called as non-probability sampling. There is no probability involved here, right? You have done based on your convenience. Okay. We will see some more examples of that one. But first, probability sampling. So under probability, systematic sampling. So imagine, in your school, okay, uh, uh, probability sampling means imagine in a school, in a class, people are made to stand in queue. So first person, third, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. And then now the teacher says all these even group people, they have to participate in sports. Then that means what is this? This is systematic sampling. Systematic. System means what? There is a pattern in the selection. Pattern is what? Every alternate person is getting selected. So when you find a pattern, this is called systematic sampling. Selecting every nth member from your population.
Okay.
Okay. You're understanding the reason why all these are doing all these we are doing, or maybe you will understand later stage when we properly do one full-fledged sum. See, what happens is these are all the basics when we are playing around with the data, because with the data only we are going to prove many other things. Now whatever you are going to prove, uh, everything is based on the data only, right? That means if the data itself is not clean, if the data is impure, if the data is manipulated, your output will also be manipulated.
Yes.
Okay, so initially we are speaking about like how data can be collected. So when data is not collected in the best way, then the output may not be in the best way, right? So for
Yeah.
example, now I told you, or imagine you have been told, find out how many students are aware about the CFA in their undergraduation. Okay. Now, what are you doing? You are asking to, your friends in St. Xavier's College, how many people are aware about CFA? So now, why did you ask only from St. Xavier's? You could have asked from other colleges as well. But then you don't know other college people. You are more comfortable with St. Xavier's because you are coming from that college. So what will you do now? You are just going there, you are asking, taking a survey, and then they are giving you some output. Now, do you think that has a very good validity? Will that be a good output?
No,
Why so?
because it's limited to only one area.
Yeah. So
And
now
yeah,
if you go to many other colleges, people might not even have heard about CFA. That is also possible. Okay, so that's why the output that you are going to bring, saying like everybody is aware about CFA, may be wrong, but then that is because your data is wrong. The data that you have pulled such kind of data that it is going to give such kind of output only.
Yeah.
Is it okay? So that's why
Yes.
how is this data collected, that is important. Okay,
Okay.
and from this data we will be doing some other experiments, some other sums. That time you will get clear picture, like why all these are important then. Okay,
Okay.
so systematic sampling, then there can be stratified random sampling. Okay, stratified random, see, like here your teacher is selecting people like this, second, fourth, sixth. If she would have selected randomly, the result might have been different.
Yes.
The result might have been different if she would have selected randomly. Okay, so that means the output is differing based on how you are selecting the sample.
Yeah.
Okay, now stratified systematic sampling, then stratified random sampling. Stratified random sampling means what? Stratified random sampling means uh, from the population of data, you are creating yes strata. Strata means what? Your group. Say for example, you are creating a group. This is all triple A rated bond. So you are segregating double A rated bond, single A rated bond. After segregating all, so here there are 10 bonds, 10 bonds, 10 bonds. From here, you are randomly selecting, maybe two bonds, one bonds, randomly selected from the strata. Strata means a common group, strata of bond. Okay, so this is called as what? Stratified random sampling.
Okay. So, but when we are being selective about the data we are choosing, and like, for example, in systematic sampling, we are only choosing certain data points. Isn't that so? That's not accurate, right? The outcome wouldn't be accurate, right?
See, no, nothing is nothing is perfect as such. Everything will have its own plus minus points.
Okay.
Okay, so everything will have its own plus minus points, because the best method might be very costly, so one may not want to go with the best method. Best is what? Like, go with the population data. That means check
Yeah.
everywhere, but that might take a lot of time consuming, as well as money. More money will be involved in it. Okay, so uh, so that will be the challenge there. Okay,
Okay.
so that's why you need to know that whatever output you are getting, see, it's not an abs. See, we will be doing some experiments with these numbers, and then we will come up with some output, which we will see in the next reading or next to next reading in hypothesis one. Okay.
Okay.
Mhm. Okay, and uh, okay, um, okay. So, but then whatever output you will get, you cannot conclude as an abstract science. What does that mean, abstract science? Say for example, I am doing some experiments here in science. Okay, in some room temperature, in with some you know chemical, in something I'm creating some output, that these molecules comes together, then this is a new innovation that will happen, new product will come, something like that. I'm creating some sort of chemical combinations, and I'm creating a new chemical, or some sort of reactions that happens in the object. Imagine now, that is called abstract science. That means throughout the world, in that room temperature, if that thing is done, okay, if that chemical reaction happens, the output is going to be the same. But then here it will differ, because You what did you do? You contacted one college and then you found out whether people like CFA or not. Then what will happen? Another person will contact some other college which will be like on the outskirts of Mumbai where nobody heard about CFA. Then the output is different,
Mm.
na?
Yes.
So that means it is not an abstract science. That means it has its own limitations.
Correct. Yeah.
Okay. So everybody, so that means it cannot be whatever you are concluding is not an universal truth. But
Yeah.
when I say 2 plus 2 is 4, it is an universal truth. Or if I say H2O is equal to water, it is an universal truth. Two molecules of hydrogen plus oxygen is equal to water. That is an universal truth.
Yes.
Okay. Whereas this is
Yeah.
not an universal truth, what we are doing. Okay, this is called statistics. Statistics is based on this data, this is the output. We cannot say anything with 100% confidence about the output. So when you are saying like, yeah, people are aware about CFA, it is just based on your data. Because somebody's data will prove something else, na?
Yeah.
Okay.
Okay.
So stratified random. See, now there are different ways to first of all create samples. To create samples, first one we saw random sample, any or systematic sample. Systematically you have created sample. Second one, what are you doing? You are creating strata.
Yeah.
Okay, you are creating
Categories. Yes.
categorizing. Yeah, strata means what? Converting it into similar groups or same groups, and then um, you are shortlisting. Okay,
Okay.
in same groups, and then you are randomly selecting. That is called strata, stratified random sampling. Then next one is cluster sampling. In cluster also similar one only, but it is representative of the overall population. Say for example MLA. So MLA is representing a constituency. MLA, MP, they are representing a region, correct? Or imagine a sports person, state level. So they are representing a state, right? From they are
Yes.
representing. So when they are representing a state, so from the state they have been picked up. Okay, in that state, they are the best sports player that has been picked up. So this is imagine one state. One state. This is another state. Okay. So when they represent overall population of that particular region, then we will call that as cluster sampling. Also, see, it is also cluster sampling is also based on subsets of your population, but in this case, we are assuming that each subset is representative of the overall population. Okay, so that is the only difference. It is very similar to strata, but then the key word over here is it is representing the overall population. So from this, so it will be assumed that from the entire populations we have picked up, the one person who is the state level player. He is representing the state.
Okay.
Okay, or in an Olympic, they are representing what countries. So that is cluster sampling. Okay, now based on the cluster sampling only, we are saying that, let's say there is some Olympic race is happening and India wins. What does that mean? It is India is winning based on what? Cluster sampling, because they represented India, whoever ran.
Yes.
So we will say like, India has the best runner in that case then, because we are assuming that person is the representation for India.
Okay.
Okay, that is cluster sampling. So based on cluster sampling, India is the first when it comes to Olympic running. You are understanding this statement?
Yes.
Because if sampling is done through some other way, you never know, in some village corner some other faster runner might be sitting. Those all are possible, right?
Yes.
Okay. So but now we are following what? Cluster sampling. Based on this person is representing India, and so he is the winner that way. So one stage cluster sampling, two stage cluster samplings are there. One stage cluster sampling means uh, one stage and two stage. Say for example, he is representing a state. Within the state, he is representing a district, particular district. Okay, so then in this district, so he is representing, this person is representing state, and then district and then state. Then it is two stage cluster sampling. fine. Okay. Then you see this one, non-probability. Now, what is non-probability? Like, as I said, convenience sampling. You are just asking your friends. So there is no probability involved here, no?
Yeah.
So that is called convenience sampling, is an example of non-probability. So they may ask you this question, what comes under probability sampling, what comes under non-probability. So I think probably I can write here, probability sampling and non-probability sampling. Non-probability sampling is convenience sampling, judgmental sampling, probability sampling involves stratified random sampling, um, cluster sampling. Within this cluster sampling, one stage cluster sampling, just 1 second.
Yes.
One stage cluster sampling, then two
Two
stage cluster sampling. Okay. Then central limit theorem. One minute.
Yes.
Okay, central limit theorem. So central limit theorem means, remember when I was telling you about that Z score. So we were learning about this mean, median, mode, mean. So central limit theorem means basically it is about learning of data. Okay, learning of data and about its mean, median, mode, standard deviation. All these learning, standard deviation, variance, all these are called central limit theorem. Okay. Mhm. So this part you don't have to read it. I will tell you, like, the extract what you need to remember here. Standard error of the sample mean. Okay. So standard error. Basically, standard error, this is an important one. Standard error is the standard deviation of the distribution of sample mean. What does that mean? That means uh, when you are taking many samples, here I told many samples you are taking, and you are taking mean, imagine. X1 bar, X2 bar, X3 bar, X4 bar, X5 bar, X6 bar. So you have got many means now. Now the standard deviation of all these means is called as standard error. So standard deviation of the distribution of sample means.
Okay.
Hmm?
So how much
Okay.
they are all deviating from their mean?
Standard deviation only. It is the standard
Okay.
deviation only. But standard deviation of what? Standard deviation of sample means. You have taken many samples, right? So standard
Right.
deviation of sample mean is called as standard error. This is a very,
Okay.
very important one. Okay, very important one. They may ask you theoretically also, and also many sums we will be doing on this basis. But then even theory becomes important. So standard error means standard deviation of the distribution of sample means. Okay. Now standard errors formula is standard error is equal to standard deviation by root n, because finally it is a standard deviation only. Okay.
Yes.
Now standard error, this is not your problem. This is just one line answer. That this you will automatically understand when we do further next sum. Okay, bigger sum when we do. Jackknife, this one word, one theory. Jackknife means again a way to sample only. Under jackknife, what happens is, say for example, I have been given the data 20, 22, 25, 27, 31, 35. Okay. Now 6 numbers are there. Now I can create many more samples out of this in a pattern through jackknife pattern. What is that jackknife? First, I will ignore 20. So 22, 25, 27, 31, 35. This is one sample I have created now. Another sample, 20. I will ignore 22 this time. 25, 27, 31, 35. I have created second sample now. Third sample. So you see, only with one data, how many samples I'm able to create. 20, 22, 25 I will ignore. 27, 31, 35. Then 20, 22, 25. Then 27 I will ignore. Then 20, 22, 25, 27. I will ignore this one. 35. So this is called jackknife. That means I'm cutting down one number each time. Okay, from the population data and creating many more multiple samples. You can read this one.
Yes, sir. Understood.
Okay. So jackknife, so named because it is a handy and readily available tool, was developed when computational power was not readily available and as low cost as today. Okay, a bootstrap method is more computationally demanding, but it has some advantages. Okay, so this kind of questions also they have asked. Um, okay, you are able to just go through this one, this paragraph.
Okay.
Okay, computationally demanding means it requires huge amount of energy. Okay, more time consuming kind of. Okay, this kind of theory they may ask. Okay, bootstrap method is more computationally demanding, and when we create more sample mean, we get standard error. Is it okay?
Yes.
This theory also can be tested. Okay, and jackknife is computationally simple tool.
Okay.
This is simple, whereas other bootstrap method can be computationally demanding. Okay, so from here, so this is the culmination of whatever we have learned so far. So from here, sums all will begin. Okay. Now
Okay.
this hypothesis testing. Okay, yeah. So what is hypothesis testing first of all? Acha, before that, here I told you to ignore certain things, and I said we will do this in some time. That was uh, where is it gone?
Yes, I think it was standard
This one.
error. Yeah.
Yeah, where is that standard error gone? Standard error. Here.
Yeah.
This one, right? Okay.
Yeah.
So what is written here? See, when you are doing one testing, but basically, what is hypothesis testing first of all? Any idea?
Yes, so we
Ah,
come up with a hypothesis is basically when we come up with a theory, but we
ah,
don't know whether it is true or false. That's why we are testing it.
correct. So hypothesis is a general statement about the
Yes.
population. Population means about any field. You are giving a general statement. Say, for example, Zepto is giving a general statement that they will deliver within 10 minutes. Okay, it's a general statement, which as a statistician, you might suspect and you want to check. Then what are you doing? You are doing hypothesis testing. Or Parle-G is
Yes.
claiming that their Parle-G biscuit has 100 grams, 100 grams, it weighs for 100 grams. This is a general statement. Or that there is salt in the Colgate, this Colgate paste. This is a hypothesis. This is a statement. Now you want to check
Yes.
it. Okay, this is called hypothesis testing. Now this can be categorized into two parts. Uh, this can be categorized into two parts. One is population variance known, and population variance unknown. Population variance known and population variance unknown. Okay. What does this mean? Some in certain case, most of the time it will be population variance unknown only. Okay. Population variance also I can say, or I can say standard deviation also. Same population standard deviation. It's one and the same. One and the same means if you square standard deviation, you will get variance. Population standard deviation unknown. This is population standard deviation known. Okay. So when you are testing any hypothesis, population variance may be known or may be unknown. If it is known, then what should you do? You should check whether it is a normal distribution or whether it is a non-normal distribution. When I say non-normal, you are able to understand, right? Left skewed, right skewed.
Yes.
Okay. If it is normal distribution, then you should use Z-test. What is this Z-test? You will come to know all this. There are various tests. Okay. Based on this, there are various tests. Okay. Then based on this, we will conclude whether the hypothesis is correct or not. So now non-normal distribution can be categorized into two parts. If n is greater than or equal to 0, the research has proved that you should have minimum 30 observations if you are doing any research. Okay.
Okay.
If it is more than 30, then you should go for z-test. If it is lower than 30, then no test you should do. No test. Fine, okay. Then here also population variance unknown, normal distribution, and non-normal distribution. Normal distribution, if it is normal distribution, go for t-test. Okay, t-test. What is this t-test? We will do all those. Okay, all this. Then if it is non-normal distribution, n is greater than or equal to 0, or n is lower than, not 0, 30. If it is greater than 30, go for t-test. Lower than 30, no test. Is it okay?
Yes.
Okay, this one you have to remember, you will get minimum one question as a theory also. Okay, for sure you will get one question from this. Okay, so it's very important one. Okay. Have you written it down or you will write later?
I'll write later.
Okay. Now we'll do the sum. When we do the sum, you will understand all this. Basically, when we say z-test and t-test, these are all probabilities. Okay, these are all probabilities. So different way to calculate probability under different circumstances. That's what it is.
So I had all of this in econometrics, hypothesis testing.
Okay. You had econometrics subject.
Yeah.
Okay.
Yes.
In BCom.
No, I did BA economics.
Okay, you did BA economics. Okay. There it will be there. Yeah. Then you will find this easy only. Yeah.
Yeah.
So now hypothesis testing. So let's understand the characteristics of hypothesis testing. So in hypothesis testing, um, in hypothesis testing, okay, in hypothesis testing, there can be 4 output. One is, first of all, what is decision rule? Decision rule means, say for example, if I say Parley G is, or what do you understand with null hypothesis, null and alternative?
Null is something we are trying to reject, and
Huh.
alternative is what we are trying to prove.
Huh. So null means what, null is whatever is the claim in the market. Say for example, Parley G has 100 gram. Parley G packet has 100-gram biscuit.
Yes.
So that is what the claim is. Okay. And you are the researcher. What is your intention? Obviously, you are suspecting. Otherwise, why will you do testing? So
Yes.
that means you want to reject the null hypothesis. That means it is not equal to 100 gram. This is called decision rule. So this is the hypothesis 100 gram, and this is rejector. Uh, statistician wants to reject this one. Reject null. Statistician wants to reject null.
Yes.
Okay, statistician, because you are not believing in this one. That's why you are checking all this, right? Statisticians or researchers wants to uh, reject the null hypothesis. Okay, this is null. This zero represents null. Okay, null hypothesis. Okay, so that means you want to accept the alternative. This is called alternative hypothesis. Fine with this one. Now
Yes.
when you try to do this experiment, you can come out with 4 output. One is, say for example, 100 gram is actually correct, and you did some sample. You went to the shop and then took some samples randomly, and then 30 plus samples you have taken, 30 plus Parley G, and you have checked, you weighed, and all these are close to acha. Say for example, the output is, let's say, 99 grams. Okay, the average is 99 gram it is coming to. Will you consider that as equal to 100 gram, or you think no, that is not equal to 100 gram?
No, it's not equal to 100 gram.
Okay, 99 gram is not equal to 100 gram. Okay. Say for example, okay, I'll give you another example. Say for example, you are claiming that you are a punctual person. So what is the null hypothesis? That you are punctual.
Yes.
Okay, so null will be is equal to punctual. Now your boss is checking your records. Okay, you are working in a company. Now in the last 100 days he checked, one day you came late. So should he conclude that you are not punctual, or what do you think? Still you say like, no, I'm still punctual.
Still punctual, I think.
How come? So that means here you are saying 99 is equal to 100 days. 99 days only you came on time, right?
Yes.
So in this case it is fine.
No, no, it's not.
In Parley G you said it is not okay, right? It is not
Yes.
equal to 100. So here it is okay.
No, it's not. It's not punctual.
Uh, maybe punctual. So your boss says, no, it's fine. 99 is equal to 100 only. It's okay. A person punctual doesn't mean you have to be 100%. Not necessary, no? That punctual doesn't mean you have to be 100%. So your boss might say like, okay, 99 is accepted. Still, the employee is punctual. It is possible.
Yes.
Okay. Now imagine, now he pulls some other record, and then, or he digs deeper, and then he finds out that no, you came to the office late 2 days. So now 98 days. Now will he conclude you as a punctual person? Maybe still yes, because even that's fine. Out of 100 days, 2 days you are late. It's okay. Remaining 98 days you have come on time, right? Okay, so that is also possible. So, but then further he digs deeper, he comes to know that no, only 97 days you are on time. Or further, let's say 96. Okay, so that means now there is a doubt coming up. 95, imagine, or 94. Now he will conclude that no, you are not punctual. That means we need to specify. Okay, we need to specify means what? Out of 100, okay, out of 100, let's say 95 times at least you have to be punctual then.
Okay.
You got what I'm trying to say here? This is
Yes.
called confidence interval. Confidence interval. He has to define that line. Confidence interval. Okay, so 95% confidence interval. So generally, a researcher will know that every packet might not be equal to 100 grams. Some may be equal to 99 gram only. Now you are not going to file a case for 1 gram. You will say like it's fine. 1 gram is okay. Okay, you got the idea what I'm saying? Confidence interval. So generally accepted confidence interval is 95%. Remaining is called level of significance. Okay, level of significance, which is alpha. Level of significance is denoted as alpha, which is what? 5%. So 5% is the liberty given. 5% is the liberty given, na? 5%. So
Yes.
that means you can say like maybe 99 gram is also equal to 100. You don't have to be that strict. I mean, you can be that strict also. It is, you are the researcher, but another researcher may not be that strict. Then another researcher will say anything 95 below only is a problem for me. So these are all possible. Okay, you're getting an idea. Confidence
Yes.
interval and level of significance.
Yes.
Okay. um, so now what will be the output? Output will be output will be what? Output will be uh, accept the null hypothesis. That means we are accepting that it is fine, it is equal to 100. Accept the null hypothesis when it is true. That means it is 100 gram, and your research also told that it is 100 gram. This can be one output. Second output can be reject the null hypothesis when it is true. That means it is actually 100 gram, but then your experiment rejecting it. Why? Because remember I told your sample might be a defective sample. Sometime back we were learning, right? Samples.
Yes.
So your sample can be defective because there are various ways of sampling. Okay, so you are doing some sort of you are doing some sort of convenient sampling, judgmental sampling. Okay, I think judgmental sampling I did not tell you. It was there. I don't know
Oh,
how
so
I
you
missed.
did.
I told judgmental.
Yes.
I did. Okay, so judgmental means like imagine you are going out to find out which political party is popular. So they are saying political party A is popular. Now you don't like that party, so you will say like this guy doesn't know anything. I will not take his opinion into my record. Then you are going to another person. Another person says political party B is popular. Then you will say like yeah, he is intelligent because you like political party B. So you will take that party as I mean that person's record opinion. So this is your judgmental sampling. Okay, based on your liking, you are picking the samples. So all these are possible. So because of which it is giving the output as reject the null hypothesis, but actually it is true. The next one is accept the null hypothesis when it is true, reject the null hypothesis when it is true, then accept the null hypothesis when it is false. Okay, accept the null hypothesis when that means when it is false, that means it is not equal to 100 gram, but still my experiment said that it is equal to 100 gram. So this is a mistake. Okay, so see, first one, this is a mistake. This is a mistake. This is called type 1 error. And this is called type 2 error. Okay, then reject the null hypothesis when it is false. These are the 4 possible output, out of which this first and last are correct. Accept when it is true, correct. Reject when it is false, correct. But then when that 100 gram was true, you are rejecting, then it is a problem, type 1 error. When that 100 gram is not true, but you are accepting, type 2 error. You got the idea?
Yes.
Now, which one you think is more dangerous?
Except when null hypothesis is false.
Uh-huh.
The type 2 error.
So type 2 error. Okay, why do you say type 2 error?
Because that means we've made some mistake in the outcome while selecting the outcome.
Yeah, even type 1 also is a mistake only, no? Okay, so type 2 is more dangerous because, see, it is true and you are rejecting, type 1 error. So you think like this, why so many interview rounds are kept in a company? Quite possible that because of many rounds of interview, 3, 4, 5 rounds of interview, imagine they have kept in a company. And so what happened, they rejected one good guy. The employee was true, but they rejected him. Possible, because probably he could not answer all the questions. Because of which, but actually he was a good guy. He could have learned and he could have done well for the company. So they have rejected. It's a type 1 error. Type 2 error is, imagine if there is only one round of interview, and imagine that that person is a wrong person. He is not a good team member, but he has been selected. Then what will happen to the team? The team will get spoiled now. You understood this?
So, in type 2 error, we are making a mistake by choosing the outcome, right? Like we are rejecting the right experiment. Is that it?
No, type 2 is we are accepting the wrong this uh, hypothesis. This is a wrong claim, but I'm still accepting as 100 gram. That is a wrong claim. It was actually wrong. But my experiment, because my experiment was also wrong, so it accepted it. Okay. So here it is accepting a wrong experiment. That means wrong claim. It is accepting a wrong claim. Okay. Now you just think this happens in many fields. Okay. You think like now HR. As I said, now imagine there are many rounds of interview they are keeping, because of which a good person can also get rejected.
Yes.
Or there is only one round of interview because of which a bad person can also get accepted.
Yes.
But what is more dangerous, rejecting a good person or accepting a bad person? Both are error, correct?
Yes.
Rejecting a good person is type 1 error. So rejecting a good person is a type 1 error. Accepting a bad person is a type 2 error. But both are error only. But which one is
But
more dangerous?
in type 2, the HR will also have regret of not choosing the right person, and then the whole team will also get affected. So type 2 is more dangerous.
So type 2 is more dangerous because one wrong person can spoil the entire team. Or I'll give you
Yes.
another one. During COVID time, imagine they are trying to create medicines. Now, two possibilities: rejecting a good medicine. Okay, rejecting a good medicine, good medicine is what type 1 error. Then accepting a bad medicine is type 2 error. Now, what is more dangerous?
Type 2, because in type 1 it's not harming anyone, and in type 2 it will be harming a lot of people.
Yeah, you heard that news, like many people getting side effects, uh,
Yes.
heart problem and all after taking injections. Then if that is
Yes.
true, then it is what type 2 error then.
Yes.
Okay, so that means that is why many checks will be done to make sure that it is okay to reject one good person, but you should not select, because if you are rejecting one good person, another good person will come in. But if you
Yes.
take one wrong person in the team, then that's it, the team is gone. Okay.
Okay.
Yeah. So this way, it is applied in many ways. Like I have given you a couple of examples, medicines and HR. It is applied in many ways like this. Okay. um, yeah, now uh, probability, power of a test, is equal to probability of type 2 error. Okay, power of a test is equal to probability of type 2 error. Say for example, probability of type 2 error is 30 percentage, then power of a test is 30 percentage. Sorry, what power of a test is 1 minus probability of type 2 error. Okay, sorry. So if it is 1 minus 30 percentage is type 2 error, power of a test is 70 percentage. 1 minus probability of type 2 error. Okay.
Okay.
Then, okay. These are some of the terminology that you should know. So null is what the researcher wants to reject. Okay.
Yes.
Null is what the researcher wants to reject. Reject. Then this all you don't have to read. If you understand whatever I'm speaking, that should be fine only. This is type 1, type 2 error. Uh, Power of your test. So this one, this table, power of your test is 1 minus probability of type 2 error. Okay. And type 1 error is equal to, probability of type 1 error is equal to significance level. That means if significance, level of significance, that means that 5% liberty that is given, level of significance, okay, if is equal to 5, that means there is 5%, there is 5% probability, that is 5% probability that if level of significance is 5%, there is 5% probability of type 1 error. Type 1 error. Okay. That means you are rejecting the null hypothesis when it is true. Okay. This kind of statements they may ask. Okay. So level of significance is equal to probability of type 1 error. Level of significance is equal to probability of type 1 error. Okay.
And power of test is only applicable for type 2 error.
1 minus probability of type 2 error is power of test.
Okay.
Because if you know, see, normally 95% is the one accepted one, but imagine you are a very strict researcher, you may go for, see, you may, it is up to you, you may go for 90. Generally people will go for 90% confidence interval, maximum people go for 95% confidence interval, and some people even go for 99% confidence interval. So if you are going for 90% confidence interval, your level of significance is 10%. Here your level of significance is 5%. Here your level of significance is 1%. Okay. So here there is 10% probability, no, here to make type 1 error. That means you are rejecting the null when it is true. That means that person is really punctual, but still you are rejecting. 10% of the time we are rejecting. That much is the risk. Here 5% of the time we are rejecting a punctual person. Here 1% of the time we are rejecting a punctual person.
Okay.
Okay.
And does power of test mean the same thing, rejecting type 2 error?
Power of test is the opposite of, that means power of test means ability to correctly reject when it is false. Power of test means what? Probability of correctly rejecting when it is false. What does that mean? Correctly rejecting. When it is false. That means, you see, probability of type 2 error is 30%. That means you are incorrectly, you are accepting when it is false, correct? Type 2 error. So power of a test is you are rejecting when it is false. Rejecting when it is false. Correctly rejecting when it is false. That is 70%.
Okay, understood.
Understood? Then, so these are all some terms. Then p-value. Have you heard this one, p-value?
Yes.
What is it?
I don't remember now, but we had like a formula to calculate p-value.
Okay, you had formula. Okay, here luckily we don't have the formula. It will be directly given to you if at all they want to ask anything. P-value will be directly given. Okay, if p-value is the probability of occurrence, you can think like this: probability of obtaining the test statistics. What is the test statistics? All, or maybe little later I should speak. Okay, about this p-value you will understand better once I do one some test statistics. Okay, so that time you will understand. Let it be now. Okay. Then uh, see, this little complicated statement, but if you understand it is good. See, decreasing the level of significance level from 5% to 1% will increase the probability of failing to reject a. So what does that mean here? See,
So the lesser the level significant LOS, that means
huh,
higher the probability of the test being correct, right?
correct, correct. Yeah. See, you can think like this. This is normal distribution. So 90 will come somewhere here. This is 0, 1, 2, 3, minus 1, minus 2, minus 3. So this is 90, and this is 90. 95 should come somewhere. 90 will be this much, right? This is 34, 34, and this is 13.5 and 13.5. I think it all comes to 95%. No? All will come to 95. Okay. So this is 95. So it is like this then. Let's say this much is 90. Okay, so that means more probability of rejecting. Okay, and then imagine if you go for 95 confidence interval, then little less probability of rejecting outside the number, or we are rejecting. If it is 99%, that means very less probability of rejecting. 99. So decreasing the level of significance, because here level of significance decreased to 1%. This is 90. So this one is confidence interval is 90%. Level of significance is 10%. Confidence interval is 99%. Level of significance is 1%. So decreasing the significance level from 5% to 1%. Acha, this one. This one is confidence interval is 95%. Significance level is 5. So decreasing it from 5 to 1 will increase the probability of failing to reject. This is another problem, the way they write. Failing to reject means you read as accept. Accepting a false null. Okay. Will increase the probability of failing, accepting a false null, type 2 error. Okay, so how do we simplify that statement now? Decreasing the significance level, that means this 99%, will increase the probability of accepting. Because in this case, we are going to accept more. When we are accepting more, so quite possible that you are accepting even your false one. Understood this one?
Yes.
Because you are largely accepting here. So you are accepting, imagine a company which is taking any person who is going there to give interview. So quite possible that they have taken a wrong person also within the team.
Yes.
So will increase the probability of accepting a false null. That means type 2 error will happen more in that company if they keep taking any person, and that will reduce the power of test.
That means
Reduce the power of test, no? Because
yeah.
correctly you are not rejecting.
Yes.
Correct, you are not rejecting, no? Correctly. Like here, in this case, what is the power of test? Power of test is 1 minus let's say for example you are correctly rejecting, um, say for example in this case 30% you are correctly rejecting, so your power of test is 70%
Yes.
power of test. Now in the second one you are not correctly rejecting, you are taking many people, so this has come down to 10%. So your power of test will go up to 90%. No, no, 1 minute. Eh,
So I think it's the other way around. When it's
yeah.
5%.
uh, okay, I said something incorrect now. Yeah, wait. First one, if I say 30%, power of a test is 70%. Okay. Now in the second one, when it is only 1%, uh, that means I'm
Correctly choosing.
I'm taking everybody in the company. So when I'm taking everybody in the company, so that means I'm taking a wrong person also. So accepting when they are false, that means uh, type 2 error is going up. So when type 2 error, it is not 10%, it has gone to 40% now. So if type 2 error has gone from 30 to 40% now, right? So power of a test will come down, because power of a test is what? 1 minus type 2 error. So it will come down from 70%, it will come down to 60%. Now, have you
Yes.
understood this?
Yes.
Okay, yeah, fine. This is okay now. Okay, so these lines are good. We can increase, conversely, for a given sample size, we can increase the power of a test. Power of a test means correctly reject only when the cost, that the probability of rejecting the null increases. We can increase the power of a test only with the cost that the probability of rejecting a true null increases. Okay, yeah, so okay, that is fine. We can increase the power of a test, that means correctly rejecting when it is false, only by rejecting a
Type 1 error. Yeah.
type 1, only by with the probability of rejecting a true null. For a given significance level, we can decrease the probability of type 2 error and increase the power of a test only by increasing the sample size. Yeah. So this is another method. Is what? Increase the sample size. When you increase the sample size, more sample size as in more number of people are coming. So for a given significance level, we can decrease the probability of type 2 error. So what does that mean? That means, like as I said, instead of selecting everybody who are coming to the company, we should reject many people. Okay. Uh, and at the same time, okay, uh, and at the same time, that means we are doing type 1 error when we are rejecting. Probability of rejecting the true null hypothesis, and at the same time increase the number of size. That means more and more people should come for the interview, so that they keep rejecting, and at the same time wrong person does not come inside the team. And then, when numbers are going up, then right person will also come into the team.
Okay.
Have you understood this? Okay, let's see. Say for example, a little tricky only, this kind of thing. See, in a company 10 people are coming for the interview. Okay, if 10 people are coming for the interview, I have to select, let's say, 7 people. So now very less I'm rejecting now. So now 7
Yes.
people I'm or 8 people I need. 8 people I'm selecting. Quite possible that out of this I have selected one wrong candidate, which
Yes.
is dangerous for me. So what
Yes.
to do here? Instead of, so because I cannot afford to reject more, I have selected. Now what if instead of 10, 100 people are coming here? Even if I have slightest doubt, I will keep rejecting that person. But even if I'm rejecting a good person, still I will get many other good people into the company.
Yes.
Okay, because I have 100
So by
candidates now.
increasing this,
So at
yeah.
type 1 error, I'm reducing the type 2 error. Type 2 error
Yeah.
will not come. I'm not going to select any wrong person because I will keep rejecting. Slightest doubt, I will reject.
Yes.
Okay, see. We can increase the power of a test only with the cost that the probability of rejecting a true null hypothesis increases. And also we increase the sample size. So when you are interviewing 100 people, you need only 8 people. So you must have rejected 92 people. That means you have rejected many people, but that is fine for you. Type 1 error increased, but at least type 2 error will not go up now, no? Because you have rejected even slightest doubt, you have rejected those people.
Okay.
You got this one?
Yes.
Okay. You have to see how they are articulating, okay? But initially, if you don't understand also, it is fine. Like 70-80% if you understand also, it is fine. Then slowly only mind will accept this kind of terminology. Or you might understand also based on your background, if you have gone through such kind of statements. Okay, if not also, don't worry. Slowly when you keep on practicing more and more, then your mind will start accepting this. Okay. Then some comes up. Okay. uh, if whatever we have done now here, if that is very tiring for you, we can stop. If not, then we can continue for half an hour more or till you get tired. What do you want
So
me to do? Hmm?
we can continue for half an hour.
Half an hour is okay. Okay.
Yes.
So then I'll do one sum also. In case if you feel tiring, you tell me. Okay, I'll stop then, because these are little bit tiring topics actually. Okay. But when we do one sum, probably it will give you even more clarity. Just go through this question now. Sums are actually very easy only, but you will get questions more theory form only.
Yes. We also only had sums. We did not have any theory.
But here you will get all theory only.
Yeah.
Yeah, just go through this question.
Yes, sir. Yeah.
A researcher has gathered data on the daily returns on your portfolio of call options over a recent 250-day period. That means this is n number of sample, okay, 250-day.
Yes.
The mean daily return has been 0.1%. That means this is our return. We have done some sampling and this is the return. And the sample standard deviation of daily portfolio returns is 0.25%. Okay, the researcher believes that the mean daily portfolio return is not equal to 0. That means the market believes that it is equal to 0. You got the difference? Okay, so the market believes it is equal to 0. So whatever the market believes,
We are
okay,
trying to
whatever,
reject.
yeah, so null will be equal to 0. 0 returns from options. 0 returns from options trading. Okay. And then alternative is not equal to 0. That means some returns you are getting from options. Now how do we check this one? So you will take some samples, like here 250-day sample. It is called N, 250-day sample. Okay, and the formula to do this is called test statistics. That means we are testing. Test statistics is equal to mean return, mean what we are calculating. So sample mean minus hypothesized mean. Hypothesized means whatever the market believes divided by standard error. This is the formula. So sample mean is what? 0.1 percentage. 0.1 percentage minus hypothesized mean is 0 percentage. This is what the market believes. Standard error is standard deviation. So standard error is equal to standard deviation by root n. Okay. So standard deviation is 0.25 percentage divided by root n is 250. Just calculate all this.
0.0158.
0.0158 percentage.
Yes.
So now you calculate all this. Percentage will get cancelled. 0.1 divided by 0.0158.
6.33.
6.33. Now what does this mean? How do we understand? What do we understand from this? See, what do we understand from this? See, the story again goes back to standard deviation and z-score. Okay, if you notice, this is very similar to z-score. Z-score's formula is what? X minus mu divided by
Mu.
standard deviation. That is z-score, na? So
Yes.
here also, remember the critical value we are doing. See, if nothing is mentioned, we are doing with confidence interval of 95%. If nothing is mentioned, confidence interval is 95%. That means 5% you are giving your liberty, kind of thing. Okay. Now when we say and one more thing here, we okay, um, um, okay, so in this case, another thing is, when we do this calculation with 95% probability, the z-score value will be plus or minus. So z-score value will be plus or minus 1.96. 1.96 means what? This is 0, 1, 2, 3, and here minus 1, minus 2, minus 3. Okay. So
So that means
1.96 means it is over here, almost at 2, this much area. Okay. So this is the critical value. If it is 90% confidence interval 90%, then the z-score that we should use is plus or minus 1.65. Okay. This, you don't have to remember anything. As in, you remember only for 95. If it is anything else, they will give you in the question. Okay. For 99%, z-score is equal to plus or minus 2.5, 2.56, 2.56, 2.56 or 2.5, 2.56 only. Yeah. But you remember this one only. 1.96 is for 95%. So this is the critical value. 1.96 minus 1.96. Okay. So now this is 6.33. So you see this is very similar to Z score now.
Yes.
This is Z score. Okay. Now this Z score is coming to 6.33. That means because this Z score is falling outside the range, if he falls outside the range, we will reject the null hypothesis. If test statistics falls outside the range, if test statistics falls outside the range, we will reject the null hypothesis. We will reject the null hypothesis. Okay, if it is falling within the range, then we will accept the null hypothesis. All these are the range. Then we will accept the null hypothesis. So it is way outside. Okay, so we are rejecting means what? When we are rejecting the null, that means we are accepting that it is not equal to 0%. It is giving some returns. Okay, now this is the conclusion. 6.33 is greater than 1.96. We can reject the null hypothesis that the mean daily option is equal to 0. So it is not equal to 0. Okay. So you take a minute, go through all this now. Or you want to see this calculation, what I have done?
Yes, sir. So in this case, we are using confidence interval.
95% confidence interval. Yeah.
Okay, sir.
Fine. Okay, now p-value. Okay, let me tell you p-value also then, because we have finished one sum. No? So, so p-value means, now we don't need to know the formula. It's a complicated formula which is not there for level 1, fortunately. See, so if the p-value is lower than the significance level, if the p-value is lower than the significance level, we will reject the null hypothesis. Okay. If the p-value is lower than the significance level, we will reject the null hypothesis. What does this mean? First of all, p-value means it is the probability of occurrence. Probability of occurrence. Okay. Probability of occurrence. I don't know, 1R will come or double R. Probability of occurrence of the test statistics. That means, say for example, like, so basically what we are calculating is what is the probability of this happening, this number. So for example,
Yes.
imagine there is a new cricketer comes in and he, in the first 4-5 matches, he has taken all 100. Okay. Now when he has taken all 100, now, and strike rate more than 100. So his records now, if you see average more than 100, that means it is better than Sachin Tendulkar. Okay, strike rate more than 100, that means it is better than Sachin Tendulkar. So the numbers are saying that all records are better than Sachin Tendulkar. So can I say he is a better batsman than Sachin Tendulkar?
Yes.
No, you cannot. Why? Reason being, now Sachin Tendulkar, the number of matches that he played and the number of matches that this newcomer played, there is a vast difference now.
Mm.
So what he has done in the last 4-5 matches, there is no guarantee that it will be repeated in future.
Okay.
So the probability of occurrence is low, na, p value.
Okay.
Got it or not? Or
Yes.
imagine
Got
there
it.
is one hero, acting in a movie, and first movie becomes a big hit. So does that mean now he is equal to some other superstars? Not necessary. Why? Because other superstars, they have proved for decades and decades. Whereas now there is only one newcomer who has done only, maybe one or two movies. Okay.
Okay.
So p value is the probability of occurrence. Here the point is, if the p value is lower than the significance level, we will reject the null hypothesis. Okay. So its probability of occurrence is not even 5%, lower than the significance level. Okay. Then we will reject. Okay. This one thing you have to know. Then so it is not becoming too much now. Should I do the next sum?
So can we continue tomorrow?
We'll continue tomorrow. Okay then.
Yeah.
Okay, so what you do, by tomorrow, you just recap this video once again. You watch it
Okay.
once again for sure, and then again tomorrow tell me wherever you are not convinced. Okay,
Okay.
and then I will, if needed, I will repeat all this wherever you are not convinced. Then we will continue with the remaining sum, and then again I will have to repeat this couple of times. I have to do this part. Okay, and
Okay.
then we will move to linear regression. So in another, maybe like in 1 week, or in 6-7 sessions, or 5-6 sessions, it will be over in 1 week.
Okay.
So this is, so fixed income also we are done, quantitative methods we are done. These are all the time consuming subject.
Yes.
Okay, then only FSA will be more time consuming one. Okay, but
Okay.
for me that is in nothing is a worry. Reason being, you are the only one, or sometimes the other guys also they come in. Okay, so I don't have a big crowd where I have to worry like too many questions will come, so I have to give answer to everybody. Nothing like that. So it is easy only for me to finish up. Okay.
Okay.
Okay, fine. We'll stop now here.